Hi, Suzanne. How's it going?
Hey, I'm good. How are you?
Good.
Did you have a nice Thanksgiving?
Yeah, we did. We did. It was good. It was pretty much the usual. It's kind of like you
Yeah,
do the same things every
yeah,
year, but they're
me
good. So
too.
did you like see your parents and extended family and stuff?
Yeah, we have a pretty small family, but my parents always have it at their house. But yeah, same old kind of thing.
Yep. Yep. I think there's good stuff about that for sure too.
Yeah,
But
definitely.
I'll wait another couple of minutes. I know we probably will have a smaller group this week.
Hmm.
Hi, Sam.
Hi.
I think I'm gonna get started because I think um most likely we're gonna have a small group this week. So um all right, guys. So for today, what I plan to do, we had a little bit more to go over last class than I had thought. So I want to make sure we touch on all that stuff. I also have some videos that I want to kind of play them and talk about them that have to do with adjusting because I do feel like that's something that you kind of need to see in action. Obviously, it's something that you need to practice too. So there are lots of, especially in Northborough, but probably in most of the offices, there are a lot of frames that are older, have been donated. I would highly, highly recommend that put some, if you haven't done this already, put some like very out of whack, like, try to make them kind of as messed up as you possibly can and then put them back into alignment, kind of like a standard alignment so that you really have some practice and you're not worried about messing up, a patient's frame basically. You guys have probably done that already, but definitely, if it's not something that you've played around with a good amount, definitely something that you should spend a little bit of time doing. But a couple things that we talked about. This is going to be a little bit of review from the last class, but there were some really important concepts that I did want to touch on, and some of them I'm just going to create a whiteboard here. Some of them were in the video that I had asked you to watch, for the last class. Um, so these may be, if you had a chance to, obviously to see the video, these might be something you've seen before, but definitely super important concepts. So let me get these into the whiteboard here. But we're gonna just, go over a couple fit concepts. So these are some basically clips from um, that video that I had. Well, if I can get my computer to save here, um, that I had you guys watch. It's the one of the Optician Works videos, basically. Okay, so let me put in this photo. Okay, so we'll just make this a little bit bigger. This I thought was a really good example of a patient that happens to be a kid who is really, fit in a frame that's much too small. Most of the time, this is not what happens with kids. Most times they're fit in a frame that is much, much too wide. I don't know if you guys have seen kids walking around, having been fit. somewhere where you're just like, oh my gosh, like they're in a frame that's like three sizes too big for them. Usually you'll see kids that are very decentered nasally, so their pupils are much, closer into the insides of their lenses than they are to the out. This is actually the complete opposite. She's actually maybe even decentered a little bit temporally. But the big problem here is that her hinges or the temples and potentially if these are spring hinges are opening to the side, right? It's definitely, not only is she kind of oddly centered in the lenses, this frame is going to be tight on the sides of her head, right? So, not an ideal fit. Have a quick image to show you of another red flag situation that relates to this. But if you ever see, these all happen to be pictures of kids, but probably more likely, like I said, to not be a kid situation when this would happen. But here is just an image of the spring hinge actually being open. Okay, so obviously not all of our frames have spring hinges, but this spring hinge is actually, being forced open because it is too tight on the size of the patient's head. So you never want to have a spring hinge need to be like it should be resting just in its normal straight position, not being forced to be open. Okay. All right. So, the other extreme here, which again is most likely going to be far more common, is this photo. So I'm just going to put this up real quick. The next one. Okay, so in this next photo, we have an image where the yellow lines are designed to be showing where the temples or the angle of the temples, I think because they're just dark and it's a little hard to see. But those temples are actually going in, right? So whereas in the first picture, these two temples are bowing out, now we have the temples actually getting narrower towards the back of the patient's head and they're wider at the front. So this again is very much not ideal. 9 times out of 10, this patient is going to be quite decentered in the lens too. But this really just talks about the actual fit, the physical fit of the frame and a little bit less about decentration. And then the ideal is, sorry, I can't click off of this one. The ideal is this last photo here, which I will put up. As you probably can guess, the ideal is that the temples would go straight back like this, basically. So the temples are, well, in this case, the temples are in red, but the angle, that yellow line is showing that, it's basically at a 90-degree angle to the front of the frame. They're just going straight back, towards the patient's head. They're not bowing out, they're not going in. So one question that I often have about fitting like this is just, well, what if you have that patient who has, really kind of a wider head, right? Like oftentimes you'll see people, who have maybe a narrower PD, but a wider head. And it's like, well, wouldn't you kind of, if you're focused on getting, their eyes centered in the lens, as we know we're supposed to do, and I'm talking, horizontally centered, what happens if they have a wide head, right? So, in my opinion, you should prioritize the eyes being centered in the lens before you prioritize the angle of the temple, right? So, more important that she would be centered horizontally, side to side in this lens than, have a perfect fit where the temples are going, perfectly straight back, right? And the reason for that is just that there are some people who have a smaller PD. If they're of a higher script, higher plus or higher minus, and usually that's going to kind of come into play around a minus 4 or +4, that's when you're going to start to really need to worry about those things. It's more important for them to, have a thinner and lighter lens, which is achieved through being centered, than it is for them to not have a frame, that maybe slightly bows out at the sides, right? Obviously, you don't want the frame to be opening at the hinge here. That doesn't make a ton of sense at all. Definitely not recommending that. But there are times when you may have to adjust the end piece, which is this little piece right here, a little bit, maybe with some pliers to open it up a little bit, just so it's not uncomfortably tight for the patient on their temples, but to allow that just the shape of their head to be accommodated because sometimes people again do have a wide head and a narrow PD. So definitely something you'll see occasionally. Couple other fits that I wanted to talk about, and I thought there were some really strong images of this in the video. So again, I'm just going to quickly put in some screenshots here for visuals. This one talks about the fit of a bridge, right? So, certain patients will have flatter bridges, right? And when we're talking about flatter bridges, it really is basically like how much does their bridge of their nose stick out, right? Like I have a very like not flat bridge, like it really kind of rises up quite a bit from like where my cheekbone is, right? But there are a lot of patients, and oftentimes this is referred to as global fit or like Asian fit. Different face shapes, different bone structures, the bridge will be much flatter, right? Almost that space between the eyes could be, really have very little relief or very little, raising to it at all. And that presents a problem because I think this picture shows it really well. You can see here that this bridge is sitting off of this person's nose completely, like it's not really touching the bridge of her nose at all, the frame. But it is touching at these 2 points down here, which are going to be very, very uncomfortable over time. So, definitely not an ideal bridge fit. This person could be really helped by having nose pads attached to the frame. Just choosing a different frame. It's not that, every Xyle frame is not going to work for this patient, but this one in particular that has this like really kind of almost pointy area here and here is not a good fit. So definitely important to remember that. And then let me show you, I have two other bridge pictures, which I think are helpful. The video showed an ideal bridge fit, and they also showed a wide bridge fit, which I think um, is hard sometimes to identify, but this is the ideal bridge fit. So what they're pointing out here is that, it's not like pressing down into the patient's bridge. It's not like, kind of bumping into her skin a ton, but it's just like this perfect kind of slope over her nose, right? I've heard people say, oh, there should be like a little bit of space here, don't have it super, super flush at the top. But again, this you can just really see is like a really nice slope, and she's not bumping into the same issue that the woman above was, with kind of the wrong part of the frame, touching the nose. And then one last one is just to quickly show you guys the wide bridge. This one I think happens more than one would think just because it's kind of a subtle thing, and newer opticians may not really like be aware that it's an issue. But this one, I mean, this has nose pads, so this could be super easily fixed. But this one is like that metal bar is actually sitting right on his skin, right? It should be, lifted up a touch here. It's always, especially with a metal frame, you always want to have a little bit of space between the patient's bridge and the frame itself. So definitely a bit wide for him. All right. And then the last, actually, no, there are two more things I want to talk about fit wise. One of them was nose pads. I feel as though nose pads can be a bit of a challenge. We talked a lot about nose pads the last class. And I do feel like that's kind of a challenge to kind of explain, how they should be fit. So I had some pictures that maybe will help illustrate this a little bit. Both of the pictures are with a person with a very high or very like raised bridge. Like they would not be someone who would like really wear like a global fit frame. Um, but this picture illustrates, a nice placement of the nose pad. Okay. So in this case, again, she has a high bridge. She has a pretty narrow bridge too. But what's happening is the nose pad itself, and maybe I'll just make a little line on here to kind of illustrate it. But the nose pad itself, just like going down this line, is completely flush with her skin. Okay, so there's no hole, there's no gap. It's turned at the perfect angle for her skin. And then directionally, the other thing that's important about this is just that you can see that angle wise, we were really talking a lot about like 20-degree angles. So you can see here that the angle that it's, kind of going up and down this way makes a lot of sense. Um, we talked about it being flush with her skin, so kind of the rotation angle, that is making sense in this case. So, we can't really see the frame. If we turned the frame to the side, we could also check that the angle of the nose pad was going up in a 20-degree angle. We can't really see that here from this picture, but it just really shows how it's perfectly flush with her skin. Now, if this person, let's just go back and refer to this picture here, if this person were wearing a frame with nose pads, the angle of her nose pads wouldn't be super vertical the way the last picture I showed was, right? For this particular patient, you know, who's wearing the Xyl frame in this case, she would need those nose pads to really be rotated much more so that they would kind of be pushed much more flush against her bridge. Whereas the woman who's down here, if you rotated them this much, like that would be way too much. It doesn't fit with her really high bridge, which is much more kind of like this. Okay. I do have one other nose pad picture that kind of illustrates a not good fit. So this would be helpful. Get this up here. Okay, so this is, I think, the same patient, and it shows a yes and a no. This one is nice and flush, whereas this one you can see that it's much too turned. And it actually isn't even touching her skin at all, right? Like, well, maybe a little bit, maybe on the backside it's touching her skin, but there's like, you can even see the shadow of it. There's like a space between her nose and the nose pad. I've definitely seen some crazy nose pad stuff, come in with patients. Like you'll see like areas like this, like just digging into the skin. Like I once had a woman come in and her nose pad was like literally kind of completely backwards and like really like getting into her skin, like down here. So, they definitely need to be thoughtfully adjusted. And when you're working with a patient, it may take you a minute, or if a couple tries to really get the nose pad fit correctly, right? And the best thing to do when you're a newer optician is just to say to them, hey, it's going to take me, a couple minutes or a couple adjustments to get this perfectly, just to kind of let them know to like expect that, because some patients will, expect that you're going to like, have this done within 2 seconds basically. But sometimes, you don't know quite how tall their bridge is. You're not sure, how much you need to rotate the nose pad. So never hesitate to kind of place it onto the patient, take a look at it, pull it back again, and then adjust that rotation or that angle, depending on what will really make it sit nice and flush on the skin. All right. Last little bit that I wanted to just recap for adjustments. Um, well, maybe two last little things, is the temples. Okay. So temples are really important. And the most common temple issue that you see, and sadly, you'll see this in our office to some extent, I have seen it a bit, Um, but the one that you'll see when you're like out and about a lot is people with super short temples. So like this situation. This is not that crazy actually. But you can see that, the bend of the temple here is before his ear a little bit, right? Like it really should be kind of like bending, a few millimeters or half a centimeter kind of back from where it is bending. And you can also see here, again, it's not like a super dramatic like situation here. But normally you'd want a little bit more temple to be able to wrap around the back of the head over here. Okay. Sometimes you'll see crazy things where, someone's been fit with a frame, um, and, you know, they have like a temple. Why does this line always get so thin? Let me get thicker here. They'll have a temple that like, you know, will literally only go like to here, and it's been like straightened out because the person who was fitting it realized like, oh crap, like it's supposed to, really be bending here, but it doesn't fit the patient, so I'm gonna straighten it out and, try to get it as much as I can to wrap around their head. So you will see sometimes, that definitely, the mark of a skilled optician who's looking at the patient's temple length when fitting them with the frames, right? Definitely much better too to have the temple be too long, than too short. I think, that probably goes without saying, but you can definitely, there's just not enough to work with if the temple is too short. Whereas if it's too long, usually you're not going to, it might look a little bit too long, but you're not going to have like fit issues with the frame. So let me just show you a quick picture, of a temple that is too long. Definitely common in kids that you'll see this. Um, okay, so this one here, too long of a temple. You can also see that it's been adjusted so it really goes straight down there. Probably would hide this a little bit if they hadn't maybe done this like fairly hockey stick adjustment here. Like if it kind of sloped a little bit more gradually and followed the angle of her head a little bit. But this one, it's almost coming below her ear. So definitely on the longer side, not ideal. And then what you do want to see, we do have an example of one that is a nice fit of a temple, just so you have a reference. Put this one in. Okay. So you can see that, you know, it's again, it's actually fairly long, but it's able to, end well before her ear. It doesn't need to be, kind of angled super down, to kind of try to hide it. Maybe it's following along the line of her skull nicely. So that's kind of, more of an ideal temple length. Couple other considerations. This one will come back to when we talk about progressive lenses, but I thought it was a really good time to just reinforce this. Talks about the vertical decentration. So let me get this photo in. Okay, so just remember that when a patient is fit with a frame, you're going to need, from the pupil height, you're going to need 18 millimeters, 17 to 18 millimeters, to the bottom of the frame, right? So obviously it looks funny too to have their eye be set too low in a frame, but you always, with a progressive lens, even with a single vision lens, you really want to make sure that there is ample space, below the lens, below the pupil, for the progressive, right? The kind of the minimum fitting height is usually a 17, seg height. So definitely important to be thinking about that. And then in turn, we don't have a photo of this, but you don't want the patient's pupil way, way, way up here either, especially for a progressive. That's going to cut off a huge amount of their distance, vision in the progressive. So just a quick reminder about vertical decentration. And then the last thing that I wanted to just remind everyone about. This is a problem that does come up occasionally, and it is kind of a pain to deal with, especially in a plastic frame. But this is when someone has long eyelashes. So I don't know if you guys have encountered this yet, but some people, obviously there are lots of like fake eyelashes at this point or extensions, that sort of thing. Um, but, if their eyelashes are touching the lens, it can drive patients crazy. It can smudge the lens. It's not a fun time. So, you do, obviously, it's ideal if you have a metal frame because you can adjust those nose pads, the guard arms to just be a little bit less constricted and tight, kind of adjust them out a little bit, and that will push the glasses away from the patient's eyelashes. That's a great way to, deal with the problem. However, with a plastic frame, there's really not as much you can do. So, definitely want to take a look at the patient if they, do seem to have really long eyelashes. It definitely happens with kids a lot, I would say too. You want to really just, kind of take that into consideration and, guide them away from a frame that sits really close to their eyes. One thing what was I going to say about the eyelashes? One thing with the eyelashes is think about their prescription. If they are a plus prescription, their lens is actually going to, you be thicker in the middle. Okay, so it's not really gonna like, this is gonna be kind of a weird drawing just because it's not actually gonna like be convex on the backside. But the thing to remember a little bit is that it's actually, if the lens is thick in the middle, like typically like a plus lens would be, it's actually going to bring the lens closer to their eyelashes. So again, this is a common problem with kids because usually when younger kids are being fit with glasses, they're a plus. And so it does tend to happen sometimes that, they have longer lashes or for whatever reason the frames are sitting close to them. And so those plus kids, sometimes will have issues with their eyelashes hitting the lens a lot. So that's kind of the last consideration there. Um, in terms of another thing that I wanted to just reiterate about fit is I spent a little bit of time last class talking about centration within the lens. So just to, give you quick visual here for centration. I drew out some pictures, if you remember, about what happens with plus and minus lens and their thicknesses. But remember that this is kind of a neat, picture of someone who's decentered nasally. The pupil here is much closer to the nasal side of the frame. So we drew out some different pictures about what happens when um, different powers are decentered, and the minus lenses are typically going to be thick on the outside, whereas the plus lenses are going to get thicker in the middle. And I just wanted to recap on that briefly because I saw some nice images that I thought would kind of illustrate that. But let me show you these. But this one, again, it's a bit dramatic here, but this is the patient's nose here, the patient's eye with their eyelashes. This is imagining that they have a plus lens, I'm sorry, a minus lens in front of their eye. Okay, now this is again very dramatic. But you can see the curve at the back, you can see the curve at the front, and how that thickens the edges, right? So if they're nice and centered in this frame and the lens is centered over their pupil, we're going to eliminate this super, super, super thick area on either side. And we're going to get this nice thin area. Okay. Now, with plus lenses, show you that image too. That is the one that is a bit more confusing because when you see the plus image, you might kind of think, well, like, wait, like, why do I want to go for the thickest part of the lens? So again, the nose, the eyelashes here, this person is nice and centered. Now we're going for the thick part of the lens, right? Like that's, kind of how plus lenses work. Now, we're not doing this because we want the thick part of the lens, but we're doing it because we want the pupil to be centered in the optical center, which is the optimal, the place of the best vision in the lens, right? However, that's also the thickest part of the lens. So, how do you minimize thickness in a plus lens? Definitely touched on this last class, but I think this image that I'm going to put up will really illustrate that well. But it has to do with lens blank size. So let me put that in. So these are 3+ lenses, okay, with different size blanks, right? So we can, when a lab, makes lenses, they can surface them into whatever size is needed for the size of the frame. Okay, so basically you can see these are all the same prescription. So for this case, let's just say they're all +4. So basically what you're seeing here is that if we have a smaller lens blank, this vertical thickness, just going to choose a yellow here, is going to be, about this size. Whereas if we have to make the lens blank larger, it's going to be quite a bit thicker. And then if we have to really go up to a very large blank, like a 75 millimeter blank, it's really, really, really thick. Okay. And that's going to be super heavy. So you might be wondering, well, why would we have to, go that big? Well, one of them is the size of the frame, right? Like if you have a very large, say, kind of 80s style frame or like a sun frame, gonna need a bigger lens blank, right? But the general reason why people need to go into bigger lens blanks is because they're decentered, okay? So if you imagine that this person, maybe let's, say that their pupil is actually right about here, and then try to draw a straight line here. They're decentered, right? So they're decentered kind of nasally if we imagine, their pupil is here. So what's going to happen is if we move over the center of the lens, let me change colors here. Briefly, let's kind of imagine that we're sliding this big lens over a little bit. Let's try to figure out how I can draw this well. What's going to happen is, okay, so now we're decentered, right? So I've drawn half of the lens, right? So we're cutting off now a lot of this side of the lens, and then let's say the rest of it is kind of over here now. Okay, so now it's not perfect, but let's say this is like the optical center of the lens. The person's decentered at this point. So what you're going to notice, if these brown lines are their frame, this lens is not going to really cut out. Okay. So I probably could have ended this lens a tiny bit sooner, but what's happening is the thickness of this lens over here and the fact that it's ending like right here means that this lens blank is no longer going to be large enough. And so rather than our 65 millimeter blank, we're going to have to go into a 70 millimeter blank or a 75 millimeter blank to get this lens to really fully fit because now this patient is decentered. And as you can see with these different blank sizes, the larger the like diameter of the lens blank, the thicker the lens needs to be. Okay. So this concept is something that's kind of, it's really important. That's why I guess I'm kind of trying to harp on it a little bit. But it's something that people don't always get. They don't really get like why a plus lens gets thicker. If they're decentered. And the reason is that you need to use a big blank and the big blanks are thick. So definitely a good thing to consider. Again, when you're over +4, I would say this is when kind of the bells should be going off in your head, like, oh, I gotta start thinking about this. I gotta start thinking about frame size and centration a ton. Definitely have had patients, especially in suns that are higher plus, and they've just been so uncomfortable in them because they're heavy, they're sliding down their nose, they're just thick, lenses because, oh, they wanted this really nice large sun, but, their script just isn't really one that can have that. So, okay. So I will gonna move on from those topics. I did want to talk a little bit about um, adjusting. And I also want to talk about determining minimum blank size because that is definitely something that is part of the exam. Good thing to know. And it actually ties right in to what we just talked about. So I'm going to go ahead and just talk about that next. So minimum blank size, right? So this is when you're like, okay, I'm working in the lab and I'm going to determine how large the lens blank needs to be for this particular patient's PD and the frame that they've chosen. So let me just put in the formula for you. So we have minimum blank size equals 2 times decentration plus ED, the effective diameter of the frame, plus 2. Thrown in that too, just for, a little generousness in terms of space. Okay. So let's imagine that we have a frame and let's just type out our frame measurements. So the A measurement is a 54. Um, the bridge measurement, um, let's say that DBL in this case is a 17. We don't really need to know the B measurement for this particular formula, but we do need to know that the effective diameter or the ED is 56. So let me click off of that so make sure you guys can see it. But let's imagine that these are the measurements of our frame. Okay. Now, effective diameter is definitely something that you want to make sure that you know exactly, how to measure that, what that is, but that's basically the largest diagonal distance across the lens. Okay, so you can do it if you just go for the biggest one because frames obviously have different shapes. Like this frame that I have on is kind of a cat eye. So it's most likely going to be a bigger effective diameter this way than if I went effective diameter this way. Okay, so you're going to figure out which diagonal measurement is the largest and you're going to go with that. So in this case, we have the A is 54, the DBL is 17, and the ED is 56. Now, in this case, remember that we need to figure out the frame PD. Okay, so we went over this in a previous class, but the frame PD in this case is going to be, it's always going to be the bridge plus the A measurement. So in this case, it's going to be a 71 for the frame. And then we need to know what the patient's PD is. So let's say in this case, um, the patient's PD is going to be um, 32 over 32. Okay, so in other words, we'll just write that that would also be a 64. Okay, but we need all of this information obviously to figure out the formula. Now, the minimum blank size is done for each eye. So we have to make sure that we do this per eye. And if you had a PD that was different, say it was like a 31 over a 33, you would have to take that into account, right? In our case, it's just 32 over 32. But basically what we have is we have the frame PD and we're going to subtract the patient's PD to determine the decentration. So in this case, the decentration is 71 minus, I'll just write this out, minus 64, and that is going to equal 7 millimeters overall. Okay, so we have the decentration of 71, which is the frame PD, minus the patient PD, which is 64. That's 7. Because they're both symmetrical, we can then just divide that in half to find out what it is per eye. So per eye, we then have 3.5 millimeters of decentration. So we can now plug that into our formula, which is up here. So in this case, the MBS, minimum blank size, is going to be 2 times 3.5, and then plus our ED is 56 plus 2. So if we do that all out, we're going to do the 2 times 3.5. So that's going to be 7. And then we're going to add that 56. And then we're going to add that 2. And what's that going to be? Let's see. Just going to calculate that out. So 56 plus 7 plus 2. So that is going to be 65. So in this case, the minimum blank size that we would need is going to be a 65 millimeter blank, right? So if there were more decentration, as in my example that was back up here, we would, blanks don't come in like they usually come in like 5 millimeter increments. So we would then have to go up to like a 70 millimeter blank if the patient were maybe decentered a bit more. Okay. So fairly straightforward to calculate minimum blank size. I have seen a couple formulas for this. Sadly, I don't think there's just a single formula because I believe the pages I gave you, like the kind of the nicer looking like color pages that I gave you use this formula, and I think the book actually had a slightly different one, but they both have you arrive at approximately the same place. You're going to be within, a couple millimeters for the calculation. So most of, just for the purposes of the test, usually, well, pretty much always it's going to be multiple choice. So there's going to be, once you do at the math, there's going to be one that you're like, okay, like this is the one it's going to be, even if you were to use, either formula basically. But that is just really quickly the formula for minimum blank size. All right. And then I do want to touch on, before we go through some of the videos on fitting, I did want to just touch on one other formula that's quite important. It is for vertex distance. So in the book, I was noticing that they really just kind of were like, all right, like this is generally how one would compute vertex distance. And they kind of were like, all right, imagine that everyone is like a -10 prescription, and it's approximately like a half diopter change for X amount of millimeters. So that is fine to kind of review that. What did they say? If a -10, I actually wrote it down, a -10 that was refracted at 9 millimeters, but is fit at 13. I think they were like, all right, like generally the change is going to be like a half diopter, um, for, I can't remember, like 4 or 5 millimeters. But long story short, we can just use the formula to figure this out. We don't have to kind of imagine that everybody is like a -10. But the take home from them using an example of -10 is like, it's not super significant in terms of changing the lens power unless you're up to a fairly high power or unless your vertex distance is changing like a ton. So for instance, like with contacts, like some of our techs are really familiar with contacts, like changing from like a pair of glasses or for where the phoropter is to actually sitting on the surface of the eye is like a 12 millimeter change. So that's like pretty significant. And so when the techs are figuring out contact prescriptions for patients who are higher plus or higher minus, that's very significant. They have to do vertexing all the time. And they actually don't use this formula. They could use this formula, but they have a vertex chart that they just pull up, and it kind of has it all on a chart really nicely laid out for them. But basically, that's going to be a pretty significant change if it's 12 millimeters. Whereas if it's only like 4 millimeters and it's a script that's like, just a couple diopters, it's not going to be a ton of difference to the patient. So anyway, but long story short, let me just go over briefly the formula for vertex distance, because this is something that will likely come up on the test. I would say of formulas, this is probably the one that you need least, honestly, the Vertex one, but it's good to know. The ones that are going to come up more minimum blank size, but really like Prentice's rule, you know, focal distance, focal length, those ones, nominal lens formula, those are going to be a lot more important. But again, good to know this one. Um, so basically what it's saying is it's the power of the lens squared divided by 1,000 times the millimeter of change, millimeter measure of change in the distance. Okay. So let's say that we're going to go with an example and we're going to use a high power lens in this case because it's going to really show us why this is important. But let's say it's a -10, and they were refracted at 9 millimeters. So the four-opter in the exam room was at 9 millimeters from. So when they brought down the big four-opter to do the refraction, it was 9 millimeters from the patient's eyes. I did ask Chris how far, do we think it is in our offices from the patient's eyes? He said probably about 12 millimeters. But then when they measured the glasses from the patient's eyes or the lenses from the patient's eyes, um, they were 13 millimeters in this example from the patient's eyes. Okay. So the important thing here is to be like, okay, well, they were refracted at 9 millimeters, but when we actually fit them, it turned out that the lenses were 13 millimeters. So we have this discrepancy of 4 millimeters between the two. Okay. So let's plug these values into the formula and figure out what we get here. So we're going to do uh, 10 squared. I forgot. I don't remember. There's like some little way of like writing squared. We'll pretend that it's that. But basically, 10 squared is going to be 100. And then we're going to divide that 100 divided by 1,000. So that is going to equal zero point 0.1. I'm just going to double check that so I'm not telling you the wrong thing. Yes, zero point 0.1. And then we're gonna do, so we've got that all set. So 0.1. Now we just have to do our millimeter of change, millimeters of change in the distance. So that's going to be the 9 versus the 13. So I'll write this out just for the purposes, but it's going to be 4 millimeters of change. So then what we're going to do is we're going to do our 4 millimeters times 0.1, and we are going to get a zero point 0.4 diopter um, difference in prescription. Okay. So basically, in this example, they're -10. The lenses were moved away from their eyes. So that is going to change the prescription by zero point 0.4 of a diopter. Okay, so almost half a diopter. So that's significant, right? So what would happen is we would make the adjustment to the lenses. We're, moving a minus lens away from the eye in this case. So it's going to gain a little bit of power there. So what we're going to need to do is we're going to have to make this prescription a bit more plus. So most likely we would be taking this down a bit, away from the minus towards the plus. So probably depends a little bit on, what the refractionist or what the doctor would decide to do. Could be, they might go all the way to a 950, probably would do like a 975, just aside a little bit on the minus. But anyway, that is how you would figure out what the vertex is. Now, if you were to do this just really quickly with say it's a like less of a like a lower powered lens, like, so let's imagine that their prescription is actually not a -10, but it's a -5 in this case. Okay, and let's kind of pretend that these distances are the same. So what we would do is we would do our -5. We would multiply that. What's our thing? I'm sorry, we would square that. So that would become 25. Sorry, not plus. That would become 25 because the first thing we're going to do is power of the lens squared. We're going to divide that by 1,000. In this case, 25 divided by 1,000. We're going to get it's going to be 0.025 is going to actually be the answer or the result of the calculation here. And then we're going to multiply that by the millimeters of change in the distance. And that is going to come out to be only 0.1 diopter of difference. So if you have a -5 person, you move the lenses away 4 millimeters, the only difference is going to be 0.1 of a diopter, right? Like a tenth of a diopter. So that's not going to be something that is really perceptible to a patient. Most people can perceive eighths of diopters, so that's 0.12 or 0.13 of a diopter. In this case, the patient can't perceive that, right? So um, they won't not not super significant. So take home from that is just with Vertex, it's only really going to come into play, at higher powers, or if you really are going a huge difference, like say, the patient, the vertex distance has moved like 10 millimeters or something, then that's going to become significant. But in relation to this, we talked a little bit about it here. There is definitely going to be a question on the test. I find these to be quite confusing. So we'll definitely talk over this for a second. There's going to be a question that relates to, hopefully it's not too blurry. It's a little blurry, but not too bad. It's going to relate to what happens if you move a plus lens towards your eye. What happens if you move it away from your eye? And then conversely, what happens if you move a minus lens towards your eye or away from your eye? What's the result? Okay. So if you're moving, let's just kind of draw this out. And again, this is one of those instances where you may like just want to um, draw yourself a little diagram, um, you know, right when you sit down to take the exam, and then just like have that for later and then forget it. Um, but basically, what we would do is let's draw our cornea. I made two blue kind of corneas. And let's say that we're going to move a plus lens in this case. So let's say that we're going to move a plus lens, going to draw it kind of like the moon towards the eye. And then we're going to move a plus lens away from the eye. Sorry, just going to change my color here. But basically, if the a plus lens is going towards the eye, it's going to lose its perceived power. So it's going to become more minus. Okay. If you move a plus lens away from the eye, it's going to gain its perceived power. So it's going to become more plus. Okay, so this might just be a quick little easy thing for you to draw out to help you remember it. And I'm just going to draw out the next one for the minus lenses. Um, but I do have a little kind of take home that you can apply to everything too. But let's imagine that you're moving now. We have well, apparently this is a biconcave lens, but we have our minus lenses that we're moving toward and away from the eye. Same deal. So if it moves so minus lens move toward the eye is again going to gain perceived power, so it's going to become more minus. And then a minus lens moved away from the eye is it's going to lose perceived power. It's going to become more plus. So it's actually, they're actually the same. When something is moved toward the eye, it's getting more minus. When it's moved away from the eye, it's getting more plus. It's just confusing in terms of like how you say it. because they're saying it as like perceived power, which is good. Like I get like why they're saying it. But it's almost like what the heck does that mean? Because perceived power is different in a minus lens than it is in a plus lens. So, it may just be helpful for you to like draw it out and then you can kind of, answer it from there. Um, but the take home from this, and I'll just kind of screenshot this too. Is that, and again, this is something that I think whatever for whatever reason, like they love to put this on the exam. But it's usually just like one question. So if you don't get it, then you don't get it. But the most important thing to remember when understanding the concept of vertex distance is that in all circumstances, more vertex different distance means more perceived plus power. Okay, so that's illustrated right here in our lower drawings, right? So whether it is plus or minus, like it's gonna, like if it's farther away from you, more vertex, it's gonna be more plus. Okay. Same thing would go if it's closer to you, it's gonna be more minus, right? So obviously more minus is going to affect, the prescription a little differently or what it looks like depending on whether it's a plus or minus lens. But the thing to just kind of, if you want like kind of okay, I'm just going to remember this one thing, vertex distance equates to more plus. More vertex, more plus. So, anyway, that's kind of a quick way to go over that. Okay, so we have a little bit of time left, and what I wanted to do just a quick screen share to just talk through a couple videos about adjusting. So let me just get that set up on my side. The biggest thing with adjusting is going to be most likely Xing, I would say, which again is when the temples, are going to go, they're going to be, crossed basically. But again, I don't have to really say that because it's going to show it in the video, but that's probably going to be the most common question. So I just wanted to talk about that first. And so there'll probably be some questions on like, okay, what do you do if, the frame is lower on the right side temporally? uh, m- More lower on the right side than it is on the left side. How are you going to adjust that frame to get it to even out? But that all has to do with Xing. So let me quickly just share this video and I'll probably um, just pause it periodically. Hold on, I have to figure out how to um, get through this ad here. Okay, so let me close my whiteboard. Okay, so perfect. Looks like you guys can see it. Um, okay, awesome. And I'm just gonna play this and uh basically pause it periodically. So I'm just gonna pause this for a second. Um, I thought it was a pretty creative idea to put these little balls on here. Like I feel like it illustrates this well. But this is the result of Xing, right? You can see in this image that if we're looking at the left lens in this pair of glasses, or the left eye wire, you can't see the lens at all. within this frame. So it's aligned really well. But on the right side, we can see quite a bit of the lens. Okay. So that means that most likely there's Xing going on and there's a twist at the bridge. So that's what he's going to address. So again, I'm just gonna stop this for a second. The first time I watched this video, I was like, what is he talking about with like open and closed? But what he means is just that like one eye, you can see the lens on a lot, and the other one, all you can see basically when you hold it at that angle that he's holding it is the eye wire. You can't see the lens at all. So he's basically just saying, okay, do that closed lens first, and then look at the one that is actually kind of the twisted open one next.
Hey Emily, I just wanted to
Yeah.
let you know that we can't hear the audio for the video.
Oh, thank you. I appreciate that. Okay.
I wasn't sure if it was supposed to have no sound or not, but it
Okay.
doesn't.
All right. Thank you.
Me too. I thought it
Um,
was like silent. I thought it was
it's
the
a silent
silent video.
video. Yeah, no, 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 no. Okay. It's definitely supposed to have sound. That's too bad. I don't know. Not sure how I would say, but anyway, so long story short, I'll kind of talk through it. But long story short is like and I think it's probably fairly clear just from watching it, watching the silent video. But basically you can see that there's, one side like is adjusted, basically just fine. The two metal pieces are lining up and the other side is not symmetrical, right? There's a huge lens area that is, as he's saying, open. So, last thing he talks a little bit about is twisting at the bridge. Okay, so really common thing to do is to grab kind of the bottom of the frame and twist it, but you want to do it, really up at kind of the nasal area of the frame. It's usually the bridge that's actually twisted and not the eye wire itself, which would be this part. So when you adjust, just hold it at the bridge, and rotate your hands, and get it, do a little bit, check, turn the frame, do a little bit more if you needed to, check and turn the frame. So, all right. So let me get out of that one and I'm gonna go to my next one, which I'm sadly assuming will also not have sound on it. I don't know. How is it? Let me just see if there's like an option here that is like talks about sound real quick. Hmm, not anything that I can see. Weird. Okay. Well, again, I'll just kind of narrate this one a bit too, but this one talks about, let me just get it going before I share again. This guy's Australian too, so he's kind of fun to listen to, but sadly, um, not gonna probably work. So, all right, let me get, how do I do? Okay, so let me just make this bigger. Gonna fast forward. So what he's saying here is he's just reminding everyone what pantoscopic tilt is. Okay, so you guys know this already, but he's saying that what people are typically doing is when they're reading or looking towards the bottom of the lens, they're looking down through the bottom of the glasses, and that is what can be adjusted with pantoscopic tilt. And what you're doing here is tilting the lens, right? He kind of, let me just go back a touch here, but basically he's trying to illustrate it for us by showing, okay, the pantoscopic tilt means that the bottom of the lens is actually getting a little bit closer to the patient's eye, and thus kind of this angle, this plane of this lens is actually getting a little bit more square or kind of parallel to the plane of the eye. So he's just gonna, the next thing he's gonna do is show us how to actually do this. So one thing that he just pointed out, and this is a very common issue with newer opticians or newer people to adjusting, you're not trying to adjust the hinge, okay? And it's very easy to just kind of default to like, oh, of course, like the hinge bends really easily, and it's very pliable metal. You want to be adjusting the end piece, so don't be kind of just bending the hinge because then the frame is not going to close appropriately. It's also a weak part of the frame, but you'll notice that he's going to go all the way down to the end piece to adjust it. So one thing that he's pointing out, and you'll see it when he does the other side, is he's rotating his wrist. So kind of like where how you're fixing Xing on the bridge, he's actually doing the same motion. He's just rotating his wrist. One obviously has the pair of pliers, the other has the frame, but he's kind of twisting them in opposite directions to get this to happen. And one thing I would just remind everyone again is he's using a nylon coated plier, which is great. I would still, just because these things get really chopped up and can sometimes be like kind of hard and like just they're not going to be as hard as metal, but they're going to be like still like kind of messed up and potentially sharp. I would still, when doing this, especially on a frame that has any sort of paint on it. So if you worked like in Sudbury or Concord with the black fins, you could really ding up the paint on that. Even with a Xyle frame, if you're using it with pliers that are metal or kind of like chopped up or chewed up like plastic ones like that, you can still kind of mar the acetate or ding the acetate. So I'd recommend that before you touch the frame, wrap it in a cleaning cloth just so you have some padding between it. But let me show you what he does next. So one thing that he doesn't do, he does place it on the table to just kind of almost do that like 4-point touch where you flip the frame over and, place it down on the table and make sure that it's not rocking back and forth. But he doesn't turn the frame and look at it like this. And I would say if you adjusted for panto, you want to do that because you want to make sure that one temple is not kind of doing this. Like you want, both temples to be lined up. You want them to have the same degree of pantoscopic tilt on both sides. So, he is saying, oh, like if one side's higher than the other, just like check for that. But you definitely, if you're doing panto, it is kind of hard to make sure that you're doing it to the same degree on both sides. So you want to, definitely check for that. Okay, so now what he's gonna do is he's gonna do like a nylon frame or like a semi-rimless frame. These, I don't know if you guys have bumped into trying to add panto to these, very difficult because it digs into your hand. Like you can't hold the bottom of the lens, right? Because you're gonna pop it out of like the nylon string. So it's like it's a pain. Like you basically have to, and you'll see him do this. You have to hold um one of the metal pieces, like that would be, I don't have a, I'm just looking to see if I have a semi rimless and I don't sadly, but what you would have to do is hold like the piece of like the end piece, or I'm sorry, the side of the eye wire here, and just like jam that into your thumb basically, which can really kind of hurt. While you're kind of bending down the temple because you just can't, like I said, hold the bottom of it because it'll just pop right out of the nylon. But you'll see kind of how he does that. Yeah, it's pretty hard to see. So he's going to show how to do the plastic. Okay, so let me pause this for a second. So this, when I learned how to do this, I was like, wow, this is like amazing. Because you guys have probably had plastic frames come in and it's like, okay, so how are you gonna add panto to this if you're not adjusting the hinge, right? Because it's like, what are you bending? It's not like with the metal, you can just take pliers and kind of like angle it down. So what he's saying to do is to heat up the frame in a frame warmer and to heat it up kind of at the corners, in the end piece, like right up here, and then to actually use your table and push it down on the table and let it cool. So he's getting it into the position of panto, it's pretty dramatic, that he wants, and he's going to hold it there until it cools, and then it will stay in that shape. So I'll just let it play a little more. So what he's saying now is he is saying that if you put the lenses into the frame warmer, you're going to craze them, which I'm sure you guys have been told before. But basically, he's saying that you're going to pop out the lenses um, and heat it up before. Sorry, pop out the lenses before you heat it up. So there are times when it's nerve-wracking to pop out lenses. I should have mentioned before that that is also something that you want to spend some time practicing. If you are working in a lens lab or you're having to do a lot of frame changes, you start to get really good at popping out lenses. I would say that popping out lenses, it does have a good element of like hand strength, but after a while you just start to kind of have like a feel for it and you start to kind of know like, oh, like, one of the best places to like get stuff to pop out is like at the nasal part. So you start to kind of be like, you just kind of start to know like where it's going to pop out the easiest and where when you're inserting the lenses into the frame, you kind of like start looking at it and you're like, all right, well, I know like for instance, the temple is going to be the hardest part to get to snap in. So when you're snapping in lenses, maybe you start by seating it in the temple and then you like work your fingers down to pop in the nasal part of it, right? So I do definitely understand the feeling of having to do an adjustment and being like, oh my gosh, like I don't want to um pop out these lenses, especially if they're like a higher power, like a higher minus. Sometimes they can be really hard to get back in. But at the same time, you don't want to craze the lenses. And, anything over, say, like 120 degrees starts to run the risk of doing that. And the frame warmers are definitely hotter than 120. So, good advice that he's giving. Okay. He's basically, I think his one is pretty much done, but he's basically like, don't mess with the hinge. But we already said that. So, okay. Let me go to the next one. I think it's the same guy, but it was a good one for a crooked frame. You can see that they're kind of crooked, crooked on him. So one thing that'll happen a lot that you may have encountered is like when people put on a frame, they'll be like, "Oh, this is crooked." And, sometimes the frame is crooked, but more often than not, they have one ear that's higher than the other, right? So you don't have to obviously point this out to them, but you should definitely always tell them that that's something that's really simple to be adjusted for. We can, do a very quick adjustment on their frame after they receive them. Or if it's a frame that's, being sold off the board, you could pre-adjust it for them, um, so that they get it adjusted already. But anyway, he's talking about kind of the classic question from the ABO exam, which is going to be like, okay, the I guess it's his left temple, the left side of his glasses is sitting much higher than the right. What is he going to do? So I'll show you what he says. So what he's saying is this, you guys I'm sure have encountered this, but it's kind of like the opposite of what one I guess would think that one would do, but basically he's saying is that because his left lens is higher, he's actually going to take the right temple, and he's going to angle that down to push up the right side. So we'll see how he does that. So he's saying to remember lower on the lower. Um, but basically, what that means is that on the lower temple side, he is going to lower the temple, right? He's going to kind of, or you could think down on the down, right? The side that's down, angle that temple down. So he's going to do it on the xyl frame. He's reemphasizing taking the lenses out. So he's saying that unfortunately it's in Celsius because he's Australian. He's saying that the frames actually have to be between 80 degrees and 115, which I feel is like really hot. But he's basically saying that that's going to craze the lenses. So let me fast forward a touch until the part where he gets to adjusting it. All right, so there's a lot of talk about crazing here. One thing that I would also, just while we're talking about heating up frames, there are some like fairly remarkable differences in acetates, and what their composition is. So you want to be cautious when you're heating frames, because some of them, like I've noticed, like the ones that, have happened to me kind of before where it gets soft really quickly are sometimes the LAI works. The LaFonts I also have found to get like almost melty soft in a much shorter time than say maybe like a Ray-Ban would. So it could really have a lot to do with the quality of the acetate, but you definitely always want to be cautious in heating something up, especially when the lens is not in it. Okay, so she obviously is an example of having the temple raised up on her left. So he's just going to quickly show what to do about that. So lower on the lower, he's going to lower her right temple. Okay. And then is he going to show us? No, he's not. Okay. I'm just going to quickly rewind to the place where because I think I was kind of chatting a little bit, but he is showing just in this clip kind of a similar idea to what we saw before with the panto, but basically he's heating the end piece of the frame and maybe a little bit of the temple itself, but mainly the end piece. And then he's going to push it against the table and let it cool just to kind of keep it in its adjustment. But that, and again, be careful of the hinge. You don't want to be, overzealous with it. But that would be how you would adjust the temples on a xylo frame. Okay. And then I also really like this technique. Here's our guy again, but I think this is really cool for wide frames because I'm sure you guys have had wide frames come in a bunch of times, and especially when they're Xyle, it's like, okay, what are you going to do with it? But he's going to kind of show what to do, whether it's metal or Xyle. Obviously, this one's metal, but you can see that it's gotten quite splayed. He has a lot to say about it before he does it. Okay, and then this. Okay, he's showing a little bit of like this one has actually too much face form. Let me see if I can stop it at the right place here, but it's just like super bowed. Pause it. Okay. So you can see this is like, I mean, it's okay. Like you could wear it like this, but he's saying like, okay, what happens if a Xyle frame comes in and it just has, way too much face form, right? So let me fast forward a bit to where oh, and then he's going to show it splayed out. So he's saying like, okay, you could reduce the face form, but then, oh no, you have your temples that are splayed. What are you going to do? Okay. So here's the metal frame adjustment. Again, please wrap it in a cloth, but pretty simple. With the metals, he's just going to bring it back to a 90-degree angle using the nylon jaw pliers. Okay, so for the Xyle frames, okay, this is again similar but I'm trying to get it at a good kind of still. Okay. So what he's saying is he's saying to heat the end piece. Okay. Again, gonna want to pop out the lenses. But you're gonna heat the end piece, and then what you're gonna do is you're gonna place that against the table. Okay. So you can place it sideways the way he's placing it against the table, but you can also place it down on the table and kind of bend in this area. I'm kind of like if I, could really show you well, I would be pushing on this particular area of the frame against the table. And that's going to bring this temple angle back in. And again, you just let it cool while holding it in that position. So he may show that next too. And again, he's just saying to avoid the hinge, popping out the lenses. See if there's anything else. You spend so much time talking about it and then you barely see the adjustment. Okay. So he is saying that you can do panto and bring in the temples at the same time. So kind of similar to what we've seen already, but I did when I first started, I remember being showed this by an optician and I remember being like, "Oh my gosh, like this is amazing. Like wow, like I had no idea how to do this," right? So he's again pushing the front of the frame against the table and he's going to let that cool and it's going to stay you know I mean it will loosen up again honestly. You could tell patients that these adjustments do loosen over time, but he's basically pushing it against the table to bring it back in. Okay. Let me stop this one for a second. Let me just see. Okay, so the last one I just wanted to show you, we do obviously do some rimless frames in our offices. Hold on. Okay, so we obviously do some semi rimless, but more rimless at our office. And I did want to have you guys just see a little bit about how um, that can be done. Um, the ones is a little blurry, but the ones that we typically see in our offices, they have these two rubber bushings that basically are compressed together with a special pair of pliers um, to get them to just stay locked together. You will see some, we don't sell them in our offices, but you will see some with like a little like nut and bolt design too. So these ones you wouldn't use the typical rimless pliers for, but you would use them for these. So they're just going to go over briefly how to adjust them. Next week we do have a little, or in 2 weeks we have a couple things about the different pliers. Okay, so this is pretty key. Like honestly, like there's this is a fairly long video, but the main messages are that when you're adjusting drilled rimless glasses, you want to be reinforcing the bushings or any place where the lens connects to the frame. Okay. So this can be done honestly, I suppose this would not be really super like the most fondly looked upon way to do it, but you can also, if you don't have the pliers, you can simply hold your hands on these points and reinforce them as you gently bend the frame, right? Rimless adjust really easily, thankfully, in general. So it's great if you have the pliers, but it is something that you can just hold as well. So he's showing just the pliers here and twisting them into place. Let me just get to the part where he shows it. So, ugh, sorry, I'm just trying to find the area. Okay, finally we're going to make the adjustments. My goodness. Okay, so he's using the bracing plier, putting it over the weak areas, the bushings. Again, you could use your hand for this. And then obviously we don't have any screws in ours, so we're not going to use that tool. But he's going to quickly, hopefully, adjust for face form. Okay, so he has the nylon jaw plier on the bridge, and he was I feel like there's just so much talking, like, and then they barely show the adjustment. But anyway, he's gonna brace it in the area where the connection is, and then the nylon jaw plier is gonna go on the bridge where he twists it. Same is gonna happen for the nose pads, right? So he has the pad pliers, and he's bracing it with the rimless adjusting pliers. Um, let's just see the pantoscopic too. Okay, so he's gonna go out to the temple. And then he's going to use that to correct the angle. And then for the panto, he's going to hold it vertically. Okay. So anyway, pretty straightforward. Um, the thing, again, like, we do have these in the offices, but at the same time, you can also, brace them with your fingers. So, all right. Um, so I think for now, guys, that is pretty much all we have. I'm going to upload this recording. We do plan to meet. The schedule is going to get a little weird in December. The next plan would be to do December 11th, which is 2 weeks. It's a Monday from today, but 2 weeks from that is actually Christmas. So we're not going to meet then. And then the week after that is New Year's Day. So we're not going to do that day either. So it'll probably be, we won't meet again until January 8th, but we will have a class on December 11th. But then after that, it's actually going to be not until January 8th just because of the holidays. So figured I'd give you a heads up on that, but I will post what the readings are. We are getting close to pretty much having covered like a good amount of the material. We have a little bit about progressives, we have regulations like ANSI standards, um, and we also have lensometry to go over. But those are really the last three big ones. So depending on how long those take us, I'm thinking like a class or a class and a half will kind of cover those things. And then there'll be like another last class or two where I'm just going to go over questions, like practice questions for like just kind of going through the test and going through practice tests and like talking out, okay, how would you do this problem? What's the, strategy? What's the answer for this? So, all right, guys, well, have a good night and I will talk to y'all soon. Bye.
Bye, thank you.
Bye. Good
Thanks.
night.
Good night.